Hello everyone, welcome back to my channel. Today I'm going to talk about the direct stiffness analysis method for 3D truss. But before I start, please click on the subscribe and hit the notification button so you won't miss new video every week. And keep watching this video until the end, see if you like it or not, and if you do, please put the thumb up as well. So the 3D truss problem that we're going to apply to is this one. It has 10 nodes and 25 bars, and we're going to modify the code that I wrote in my last video. If you haven't watched my previous video, please check the link in the description. I talk about the direct stiffness analysis method for 2D truss and apply it to an example. And this week we're going to modify this code for this 3D truss. So first I'm going to run this code to show you what it looks like. So this is the result that we get. This is the undeformed and deformed structure. So this code is for 2D truss. We have the result here for axial forces and reaction forces, and also the deformation at each node. Okay, so I will start modify this code. So for 3D truss we have 3 axes, X, Y, and Z. So for each node we need to add one more item. So for example, this is X, Y, and we need the value Z for each node. And for the bar here, it is still 2 items in one row again, but we need to change this following the example here. So to make this video as short as possible, I will skip this part. I already have the information here. So this is the value for X, Y, and Z for each node. So the first node here, we have this value. You can check the value for node number 1 here. The X is minus 37.5 and the value Y is 0, and for Z value is 200 inches, and we need to input each value for all the node here, and this is the information for each bar. So the first bar here start from node number 0 to node number 1. So this is the first bar. Because the Python array start with the value 0, so the first node is the number 0. So it will not like in the picture here. For example, the bar number 1 will start from the node at the start point is 1 and the end point is 2. So in the Python code we need to input 0 and 1. And the model of elasticity is the same as previous example, and this is the area for each member. Next we need to add the apply forces, and we have the forces here for node number 1, 2 and 3 and 6. So I will change this. So node number 1 in Python code will be 0, and value fx equal to 1, and fy is minus 10, and fz is minus 10. So for x we'll start with 0, y for y-axis it will be 1, and z-axis this value will be 2. So this is the x-axis, and this is y, and this is z, and the value here is minus 10 and minus 10. So we have the load input at the node number 1, 1 minus 10 minus 10, and 1 minus 10 minus 10. And next we need to input another load at node number 2. So this is will be value 1, and for x-axis is 0, so we don't need to import any number because this array is already 0. So we need to import only the load at node number 1 for y-axis and z-axis, and the value is minus 10 minus 10. And next is the load for node number 3, so this will be value 2. And for the x-axis and for the y and z-axis is r equal to 0, so we don't need to import anything. And this is 0.5. And I will copy and paste, and this will be the value for the force at node number 6. So this is number 5 and 0.6. Next we need to add another value here. We have 4 pin support. For each support has 3 degrees of freedom. So the value here will be the array here will be 9 items. Sorry, it should be 12. So I'm going to copy and paste it. Okay, and now for the next one we need to define the condition of the degree of freedom. So for node number 7, 8, 9 and 10 they are pin support. So the first one will be 6 because this value here is 7. In Python we need to input the number 6. And for the value 0, it's defined as a fix. So this is for the pin support at the node number 7. Next will be for the pin support at node number 8, and we need 2 more. because we have 4 pin support, and this value is 8 and 9. Okay, so everything is the data here is already input. Next we need to adjust some code here in the function Truss analysis, and also for the function plot. So first I'm going to adjust the function plot here to see if I put information here correctly or not. So I'm going to add the hashtag here, because I don't want to run this line. So I only want the code to run the plot function here, and I'm going to remove this because I don't want any error during the run. So for this function we need to add another axis. So I'm going to copy this and paste. This will be zi and zf, and the value here will be 2, and this is 2, because the value node here we have 3 column, x, y, and z, and we need to put another information here for the z-axis. So this will be zi and zf. Okay, next we need to define this plot function as a 3D plot. So I need to add a line here. And let's run this. Okay, so this is the undeformed shape of the structure, but I don't want to plot in this window because it cannot be rotated. So I need to add a line here and run this again. Now I got this this plot, and you can see that I can rotate this plot, so it's more easy to view the structure. I think this legend here is too small, so I change this to 14. So this function now is okay. So next I will copy this and paste it again, and I will start changing this function. So the doif here will be 3, because for the 3D truss we have 3 degree of freedom for each node, and we need to change something here. This will be 3 also, and the value 2 here will be changed to 3, and this one as well, and also this one. So you can use this value as the value here. For example, this will be changed to doif, and also doif, and this one as well. sorry, I think this one should be 4. I make a mistake here because our support here is a pin support, and there are 4 support in this structure, so the value here will be 4. So now we can run this code. So I'm going to delete the hashtag here and also this one. Okay, now I will run this code. So this is the structure for the underform and the form shape. You can see here, and this is the result of the analysis. Okay, I think I need to change the scale here to make it easy to view, and I clear this first, run the analysis again. Okay, so this is the underform and deform shape of this structure. Next, I will verify the result here or with the model that I already modeled this in SAP 2000. So the first one that I want to check is the axial force. So I will check the bar number 1 here. You can see in this picture. So the first bar locate here. So the axial force is 1.9, and you can check with this value. And let's check the last value here. This will be the bar number 25, and this is the bar number 25. This one is minus 15.8. So it's match with this number. So the axial force are okay. And now you can check the reaction force also. So you can check this node. This is node number 10, and this is the last support. So this will be the support at the node number 10. So the for the x-axis, the value of the reaction force is 12, and you can check here. And for the y and z, 8.2 and 14.2. You can check here, 8.2 and 14.2. And the direction are all positive. So you can see here the values are all positive. And next you can check the deformation. So I will check this. This is the node number 1. This one. So the value in this row. So for the x-axis 0.32 and y-axis -7, and for the z-axis is minus 0.86. so you can check with this value. And for this deformation at row number 7, 8, 9 and 10, they are 0 because it's located at the pin support. So this code here okay, so you can use this to run to do the structural analysis for 3D truss. And this is the undeformed and deformed structure. Again, if you haven't watched my previous video, please check the link in the description so that you can know how to write the Python code to do the structural analysis for 2D truss first, and then you can watch this video for structural analysis of 3D truss. So this is it for this video. I hope you get the idea and can do this structural analysis by using the Python and direct stiffness analysis method by yourself to apply to your own project. And thank you for watching. I'll see you guys in my next video. Thank you.